Okay, so today what we're going to do is look at another way that you can organize your data so that you can find probabilities. And it's called a probability tree. And it's usually used when you already know the probabilities. Okay? So it's usually used when you know the probabilities. The tables are usually used when you just have the raw data. How many cats wore hats, how many didn't, right? That's just numbers of cats. But here we're going to have the probability. What is the probability it's going to rain? 85%. And generally it can be given, and it could be given to you as a percent, or another way of writing a percent is a what? Decimal, or there's one more way you can even write it as a fraction, right? So you can have any of those ways that you write probability. You usually know the probabilities. Usually. Sorry, you better put usually. And that's how we know that a tree works great. All right? So we're going to talk about how to construct one. Then we're going to talk about how to read one. Right? So I'm going to do that first. Now, you might not know me very well, but you know I'm going to do it my way first, and then we're going to talk about through it. We'll go through the lesson, and they tweak it slightly on in Education Perfect, but there's some things I want to show you. Okay, to use a probability tree, first, to draw the tree. Okay? The first thing is you're always going to have a start. And I learned it to put start as the word, that's where you begin, right? You don't have to write the word start, but it just gives you a place to branch off of. And then, each event, what's an event? The thing that you, right? An event is a thing you get, right? Okay, so rolling a 6 is an event. Remember that? So each event gets a branch. So let's say we were flipping a coin. Okay? So let's say we're flipping a coin. For example. What can happen? What events can you have when you flip a coin?
Tails.
There you go. And in no particular order. So tails, or you can get a heads. And that's what the branches look like. We can get a tails, or we can get a heads. So each event gets its own branch. Are there any more possibilities when you flip a coin? Nope. So just those two branches. Yeah? Now, what if I had been rolling a die? How many different possibilities are there? 6. So how many branches would I have? 6 branches. Everything gets a branch. Now we've done flipping a coin before. What is the probability of getting a tails? Do you remember? 50%, right? So you would label the branch with the probability. It's 50% for tails, 50% for heads. Now, is it always going to be the same? No, it depends on what you're measuring, right? And many times they're just going to give you the probability. Okay? So label the branches with the probability. Whoops. So if I told you the probability was 0.15, you'd put 0.15 on the branch. That's the same as 15%, right? What if they give it to you as a fraction? Just put the fraction on there. Now, if you were doing the math, using the fraction might not be the easiest way, but remember, your handy-dandy calculator can now do any kind of math, right? You can do anything you want to with fractions by using that machine. Yeah? Now that you know how to work it. All right. Then, so that's how to build it. Now, let's say that I was going to flip the coin twice. Well, this would be what could happen on the first try. On the second try, what if I got a tails the first time? What could I get the second time? There you go. So branching off of there, I could get tails again, or I could get heads again. What if the first one I got a heads? What could I get the second time? Tails or heads, exactly. So you could continue this branching as many times as you flip that coin. So 25 times, you'd have a lot of branches, right? But what I want you to do is always label the experiments. Remember, the experiment is when you actually do it. So the first experiment, I did it. The second experiment, I did it. And what's going to go on each one of these branches? 50%. Okay. Now, change colors a bit. This is a set of branches. They go together, don't they? Those two branches? Because that's what happens on that particular experiment. And they will always add to 1. Or in percent terms, 100%. So if you have the branches and they're not adding to 1, then, or 100%, depending on what format you have it in, then your probabilities are not correct. Okay? So they should always be there. Okay? All right. Step 4. To get the probability, simply follow every branch that is a success. Because remember, probability is finding the number of successes, right? So just follow every branch that is a success. So let's say I want a tails and then another tails. Yeah? So we're going to follow the branches that lead to tails and tails. So, from the start, the only branch that leads to tails is that one, isn't it? Okay? And then, to get to the second tails, I have to follow that branch. Right? So, this is the only one that works. Because if I go here down to here, I get heads. I don't want that, right? I want a tails and tails. So the only one that happens is I can get both tails. 2 tails. Okay? So that would be written as the probability of 2 tails. And you have the percentages already there. So now we need to find out what to do with the numbers, and that's very easy. To get the probability, you simply multiply along the branch or branches. Now again, you're only considering the ones that are successes. Can you not see? Oh, multiply. Hey, why isn't that? I have more room, don't I? It says branches under there. Multiply along the branches. Well, it's not showing you the whole thing, but there it is. Multiply along the branches, okay? So, right? All right. So we're going to look at some examples, and we're going to go through the Education Perfect lesson where they show you all of this because it's got some great visuals. It's a little slow, but we'll make it through. We're going to spend a couple of days doing probability trees because, again, the most important thing that you're going to do here are two-way tables. All right, well, basic probability, knowing what a complement means, two-way tables, and probability trees. If you can do those 4 things, you'll sail through this assessment. Okay? All right. So let's just go to the lesson and talk our way through some of these. All right. Okay. For this, you can just still stay in your notebooks for right now. Probability trees give us another way of displaying the events of probability. So by this lesson, you're going to be able to sketch a probability tree and then calculate the probability of events happening by using that tree. Right? So we're going to draw the sketch and do it. So a tree diagram is made up of branches, just like a tree, but notice they went up with these, but we're not going to do that. I want you to always draw them horizontally. They're just easier to read if you do it across instead of up. Now, technically, it makes no difference. But aesthetically, it makes a big difference. Because how do you read when you read things? You bet. You don't read up and down, right? Okay, so, okay. So here we go. Here's an example. A coin and a die are thrown at the same time. So you're going to toss a coin, throw a die, right? So it's a lot of possibilities. There are possibilities for the coin, and there are possibilities for the die. Does that make sense? So even though you're doing them at the same time, isn't that the same as if I tossed a coin first, then threw a die second? Yeah? Instead of, if you did it at the same time, actually, how could you do it at the same time? I guess you could. To use two hands, right? So that's two different experiments. Do you agree? Roll a die, toss a coin. I can't get it right. All right, so there we go. So we're going to list all the outcomes in a tree diagram. So we have two events, coin or a die, and each one of those is going to get a result. Okay, so here we go. Notice they don't put start. I would really prefer if you put start. It just gives you a grounding. Okay, so start. So they did the die. They did the coin first because it has fewer things, so you'll end up with being a little more organized. On a coin, you can either get a heads or a what? So you'll see there they put heads or tails. And then if you got a head and then you roll the dice, you could either get a 1 or a 2 or a 3 or a 4 or a 5 or a 6, right? Now, if you got a tails, you could get the same things. So if you look at this tree, this is a list of everything that could possibly happen to you. So if you were doing this the way I do it, you would have start here. This would be the first thing, or you could label it coin. Even better if you label it something that makes sense, right? And this one is the die. So the possibilities for coin is there, possibility for die, branching off of each one of those. Okay? No, you don't have to. It's in here. So you don't have to redraw this. It's huge. Okay? Now, what I do want to show you, though, is what they've done on the side. Because they've done it something that's really nice to keep you, if you're going to stay focused and organized. Notice here, they put H1. What does that stand for, you think? Heads and a 1 on the die, exactly. So H2 means you got a heads, then a 2. H3, H4, H5. Now, you don't have to do that, but all they're doing is they're labeling the branches. So if you look at the one for H6, that means they followed this branch to heads and this branch down to 6. And that's why they labeled that one H6. It just keeps you organized. You don't have to do it, but we'll see. Right? It'll help you if you're getting frustrated or unorganized. It'll help you keep organized. So we'll look at it and we'll do it both ways. Now, generally what happens, though, is you wouldn't write H1. You would write the probability of an H and a 1 and then equals. And we'll get there. Right now they're just kind of leading you into it slowly. Okay? And then we'd have the probability there. So you'd already calculate every probability for every single one of them already when you draw your tree. Again, you don't have to because that's a lot of probabilities on this, right? But do you think they're going to be pretty similar? They're all going to be the same. Why? Heads and tails is the same. Rolling a 6 on a die, they're all the same, right? So they're all going to end up being the same anyway on this particular one. That's not always the case, though, guys. All right. So there's your tree. So let's just do a couple of these together. Complete the tree diagram below, labeling each branch. The game involves flipping 3 coins. So they've started it. So what we have so far is our start, and we have the first coin, right? But we're going to do it 3 times. So the next one we're going to have is the second coin, right? So from heads, I need to branch out and get what? Heads or tails. From tails, I need to branch out and get heads or tails. No big deal. But this one we're going to do it 3 times. So now we have the third coin. So from each one of those is going to get 2 more branches. Now, what I want you to pay attention to is how quickly these get really congested. So you need to write big. Leave lots of space, because look how much space this is taking. So we'll do heads, tails, heads, tails, heads, tails, heads, tails. Okay? So let's just label a couple of them. I'm going to draw the branch, and you're going to tell me what I should label it, eh? So if I go from here to there, what would that label be? HTH. Yeah. You went from heads to tails to heads. So that's the probability of 2 heads and a tail. Okay? Probability of 2 heads, 1 tail. Can you see any other branches that would give me that same result? Because remember, in probability, the order doesn't matter. Yes?
All the other ones.
All the other ones would give me a heads and a tail, 2 heads and a tail?
Yeah, they could.
Well, look, this is heads, then heads and tails. Does that one work? Yep. That one works. Any more? Tails, heads, heads?
Yeah.
Tails, heads, heads? Remember, the order doesn't matter. Any more? No. So there are more branches that work. So 3 of those branches would work. Right? So remember, don't be just looking for one branch and be done. You can have more than one branch. Good deal. All right. 2 spinners. You're going to draw the tree. So each spinner has 3 different things. On the first spinner, you can get a what? And on the second one, you're going to get a what? So the first, they started it off for you. So the first one, you can get a 1, a 2, or a 3. And then each one of those is going to branch off 3 ways. And all of them are going to be what? A, B, C, all the way down. Good. So for the first spinner, second spinner, and I like the word start. Okay. Now, none of these have probabilities on them, but we're just practicing drawing the trees right now. How's it look? Can you draw a tree? Okay. Good. All right. Now we want to talk about how to calculate the probabilities. But remember, all you need to do is find the branch that you want that represents the probability. Could there be more than one? Yes. And then I'm going to take the probabilities along those branches and do what with them? Multiply them together. Good job. Okay? So it's always multiply as you go across the branches. So if you look at their example here, they want to go from A to another A. This one is 0.7. This one is 0.6. So multiplying those together, 0.42 is the probability. And because these have, notice that they have different probabilities on them. This first one was an A, but it was 0.7. The second one was an A, but it was only 0.6. They don't have to match. You're going to get the probabilities from the problems. Okay? So this would be the probability of A, then A. In other words, I need to indicate not just 2 A's, but that I got them in that order. Does that make sense? First one was an A, second one was an A. Any others give you an A and A? Nope, that's the only branch that would do that. But how about this one? AB and BA. I can get AB and I can get BA. So how many of them give me that combination? 2 of them, right? So it's 0.7 times that, 0.3 times that, and you get 2 probabilities that work. So we need to talk about what to do there. If two branches give you the probability, you'll still multiply across to find the number you need, but then what you're going to do is add the 2 together. So a while ago we had 3 different ways to get heads, tails, heads, or whatever it was. So we'd find the probability for each one, and then what would I do? Add them together. So both operations. So what is the operation when you're going along the branches? Multiply. But what if I end up at the end and I get more than one that works? Then I'm going to be what? Addition, using addition. So you've got to make sure you know which one to use. And that's going to be your hardest goal here. Drawing the trees is usually not very difficult for most students, but knowing when to do which operation is going to be. So we're going to practice quite a bit of these. Okay? All right. So here they're just going to Look at another one. Marcus is bored at work. He begins throwing paper into a bin several meters away. After lots of practice, he works out that he has an 85% chance of getting the paper in on each shot. Use a tree to calculate the probability that he'll miss 2 shots in a row. So he's going to throw the paper twice at the wastebasket. Yes? So, what can happen on the first time he throws that? He can either what? Get it in, he can either make it in, or he can miss it, right? So that's 2 things. So let's draw it without their instructions and see if we can get it done. So first, we have a start, yeah? I know I'm drawing over that, it's no big deal. And he can either make it, so it can either be in, or it can be a miss. Now you could abbreviate whatever letters you want, doesn't make any difference. As long as you can understand it and it makes sense, it makes no difference. Then, that's the first time he throws the paper. But he's going to do it a second time. So what can happen? Yeah, he can either get it in or he can miss from each one of those. Okay? 99% of the time, the branches are always going to be even. If this top one branches twice, then the bottom will branch twice. But there is a chance that it doesn't branch evenly, but we'll talk about that in a bit. Okay? If we need to. Now, he has an 85% chance of getting it in. So that's getting the paper into the thing, right? So that's an 85% chance here. That's 85% chance there. And that's 85% chance there. Everywhere, every branch that leads to the word in, right, is 85% chance. Well, because it says 85% chance of getting the paper in the basket. Okay? So, yeah. Now, well, remember what I told you about these 2, because they don't tell me how much he misses. But that set of branches has to add up to what percent? 100%. So all I need to do is take 100% minus the 85% that I already have, which is going to give me what? 15%. So every time he misses, it's a 15% chance that he misses for everywhere he misses. Yeah? Not bad, yeah? So make sure you if you know one, you can find the other by simply subtracting it from 100%, or 1 if it's a number. Okay? So let's just walk through this. So there's our thing. It's got in, miss, in, miss. Okay? So we have, then they put the numbers in there, 85%. Now they changed the percents to decimals. Can anybody know why? So yeah, you can't multiply with percent. You have to change it to a decimal. You can add percents, but you can't multiply with them. Good job. Yeah, so they change it to decimal so we can do the math. Good deal. Okay? So, if he misses both shots, which branch has missed both shots? Miss. So right there. So it's 0.15 times 0.15, which gives us 0.0225 as his probability for missing both shots. So how likely is it that he's going to miss both shots? Yeah. 0.225, 0.0225, so not very likely, is it? Okay? Excellent. Here we go. Let's see. Oh, they just calculated all of them. It's no big deal. All right. So, here we go. The class is selecting 2 students, 1 male and 1 female, to present at the school assembly. 2 male and 3 female students have nominated themselves. A tree diagram showing the possible outcomes is shown below. So, for the first one, you have 2 branches. Yeah? So, calculate the probability that Jed and Samantha speak at the assembly if the students are selected at random and are equally likely to be selected. So, first of all, how many boys do we have to choose from? 2, right? So, you're going to choose either that one or that one. So, what do you think that's a chance of the probability of? 50, right? 50%. You have a 50% chance of selecting Jed, or 50% chance of selecting Nico. So, you're going to need these values. You could also think of it as 1/2 if you wanted to, or 0.5, or 50%. Doesn't make any difference. I already saw that the answer is in a fraction, so I just did a fraction. But it doesn't make any difference because if you're working with fractions, you can use your calculators, remember. Okay? But now, it's not going to be the same here when you get to the girls, though. Why? There's 3 of them. So each one of them has a 1/3 chance of being chosen, right? So in this case, that's another reason they use fractions, because does 1/3 make a nice decimal? No. And so she has a 1 in 3 chance, she has a 1 in 3 chance, she has a 1 in 3 chance. We're going to pick 1 out of the 3. So you see, we can also do them with fractions. And in this case, the fractions make more sense because decimals, you would have to round them. And we don't want any rounding. Okay? All right, so you'll fill in the probabilities. And now we need to find the probability of the thing. So we're going to calculate the probability that Jed and Samantha speak. So that means I can go back. All right, there we go. It means Jed, then Samantha. So Jed, we said his was 1/2. Samantha's is 1/3. We're going along the branches. That means we're going to do what with them? Yep. And so multiply straight across. 1 times 1 is 1. 2 times 3 gives you 6. So the probability of Jed, then Samantha, is 1 out of 6, or 1/6. Look at this bottom number. What is it? Yeah, the denominator, which is 6, though, right? How many total branches are there at the very end of this thing? And it's always going to be that way. Okay? So if you got 1/5, I'd worry. Okay? That's if everything is equally likely. Okay? So 1/6 is their answer. There they show you the completed tree. And they show you the working. I don't know what that 1/2 of 1 is. Okay? So complete the table below. You've got all the information you need. Go!